Hi everyone, today we are discussed about the topic graphs in data structures. What is meant by a graph? A graph G consists of two things, a set V called the set of all vertices and a set E called the set of edges. This set is E is the set of pair of elements from V. That means a graph contains must and should contains the vertices and edges. Then only the graph will be completed. The graph contains vertices and edges. Vertices can be represented as V1, V2 and V3 and V4. The edges are the connection between two nodes are called the vertices or edges. The connection between two vertices is called the edge. That is, in a given example, there is a 4 nodes V1, V2, V3 and V4. There is an edge V1 to V2, V1 to V4 and V1 to V3, V2 to V3 and V3 to V4. There is a connection between two vertices. There is an edge between two arcs are called as an edge. What is meant by a digraph? A digraph is also called as a directed graph. It is a graph G such that G consists of vertices with edges where V is a set of all vertices and E is a set of ordered pair of elements from V. That is, there is a must and should contains the directions. V equals to, there is an example with 4 vertices V1, V2, V3 and V4. There is an edge for every direction there is an edge. And there are 2 vertices between them. We have to look it on. Next, we have discussed about weighted graph. What is meant by a weighted graph? A graph is termed as a weighted graph if all the edges in it are labeled with some weights. For example, we have an example in a graph. There is a 4 vertices V1, V2, V3 and V4. For every connectivity between 2 vertices as an edge, there is some weight in that. That weights in a graph is called as a weighted graph. It can be occurred in undirected graph and directed graph. Also, there is a weights in the graph. Next, we have discussed about adjacent vertices. A vertex Vi is adjacent to another vertex Vj. If there is an edge from Vi to Vj, that means we have to represent an edge from Vi to Vj, then it is called as an adjacent vertices. V2 is adjacent to V3 because V4 is not adjacent to V2 because there is an edge between V2 to V3, so it is called as an adjacent vertices, but there is no edge from V4 to V2, so it is not an adjacent vertex. Next, we have discussed about self-loop. What is meant by a self-loop? If there is an edge whose starting and ending vertices are same, that is Vi and Vj is an edge, then it is called as a self-loop. That means if there is a starting point and the ending point are equal, then it is called as a self-loop. Parallel edges. If there are more than one edge between the same pair of vertices, then they are known as parallel edges. If there are more than one edge, that means for 2 vertices there is a one edge, then it is called an edge. But for 2 vertices there has more edges. That means 1 or more, 2 or 3 edges. Then we are called it as parallel edges. In a given example, V1 and V2 are parallel edges because there is an edge from V1 to V2 and there is also an edge from V2 to V1. In the given graph, it is a undirected graph, but we have to take it in a directed graph also. In that we have to discuss, and that we have to must and should give the directions. In the directions, we must and should have 2 directions for the 2 vertices. Then only we have parallel edges. Next, we are discussing about multigraph. What is meant by a multigraph? A graph which is either a self-loop or parallel edges. That means, what is a self-loop? We have only starting and ending points are same. Then we have called it as self-loop. And parallel edges. The edges between same pair of vertices. If there are more than one edges between the same pair of vertices, that means 2 vertices have more than one edge, then we are called it as parallel edge. A graph which is either self-loop or parallel edges or both. That means either self-loop or parallel edge or both or have, then we called it as multigraph. What is meant by a complete graph? A graph G is said to be a complete graph if each vertex Vi is adjacent to every other vertex Vj in G. In other words, there are edges from any vertex to all other vertices. That means a graph is complete graph. A complete graph means every adjacent vertex must be has another vertex. For example, give it in a given example, V1 to V2 and V1 to V3 and V1 to V4 there is an edge, and V2 to V1, V2 to V3 and V2 to V4 there is an edge. V3 to V1, V3 to V2 and V3 to V4 there is an edge. That means for every vertex there is an adjacent vertex for any and all other vertices. Then we have called it as complete graph. What is meant by a simple graph? A graph, if it does not have any self loop or parallel edges, that means the graph does not start with a vertex and end with a third vertex only, then we have called it as self loop. And parallel edge, that means more than one edge for two vertices, then it will be called it as a parallel edge. So it does not have any self loop or parallel edges, then we called it as simple graph. What is meant by isolated graph? A vertex is isolated if there is no edge connecting from any other vertex to that vertex. That means there is no connectivity to that vertex to any other vertices. Then that vertex is called as an isolated vertex. In the given example, we have 5 vertices V1, V2, V3, V4 and V5. But V5 has no any edge. There is no edge from any other vertices. So V5 is called as an isolated vertex. How to calculate the degree of a vertex? The number of edges connecting with vertex is called as a degree of a vertex, that is Vi, and it is denoted as degree of Vi. That means V1 is connected to V2, V1 is also connected to V3, V1 is also connected to V4. So degree of V1 is called as is denoted as 3, and degree of V2, that is also we have to count the number of edges connecting to that vertex. Then we have to calculate the degree of a vertex. For a directed graph, there are 2 degrees, in degree and out degree. In above we have discussed about the undirected graph, but now we have discussed about the directed graph. In directed graph, there are 2 degrees. There are in degree and out degree. In degree means number of edges coming to the vertex. Out degree means number of edges which are coming out from the edges. That means we have to coming into the vertex is in degree and coming out to the vertex is out degree. For example, in is given below, that is the in degree of vertex 0 is there is no in degree because there is no vertex is coming to that vertex 0. So the in degree of 0 is 0, and the in degree of vertex 2 is now the in degree will be coming from 0 only. So the in degree of 2 is 1. The in degree of 3 is it coming from 0, 1 and 2. So the in degree of 3 is 3. Like that we have to calculate the out degree. Out degree means the outgoing vertex. That is the out degree of 0 is 0 to 1 there is a vertex, 0 to 3 there is a vertex, and 0 to 2 is a edge. So the out degree of 0 is 3, and the out degree of vertex 1 there is an edge from 1 to 4. So the out degree of 1 is 1. The out degree of 1 is 1 to 4 and 1 to 3. So the out degree of vertex 1 is 2. Graph is a mathematical non-linear data structure, so representing many physical structures. It has found application in geography, chemistry and engineering sciences. A graph, G, vertices and edges of must and should have we have to mention. An edge connecting a pair of vertices and may have weights such as length, cost and measuring instruments according to the length. The vertices on the graph are shown as points or circuits, and edges are drawn as arcs or line segments. There is an example for graphs. The nodes can be represented in circles, and the two vertices can be connected with an edge. The edge can be represented as a line. There is an directed graph and undirected graph, and there is a weighted graph and unweighted graph. The types of graphs are directed graph, undirected graph, simple graph, weighted graph, connected graph, and non-connected graph. The directed graph we have discussed about that there is a must and should we have directions in the graph. Undirected graph means there is no directions. Simple graph means there is no loops in the graph. Simply we have only don't have self loops and parallel edges in the graph. The graph is called as a simple graph. Weighted graph means the graph must and should contain some weights. Then we have called it as weighted graph. Connected graph means if there is two graphs, the must and should we have a connection between two graphs, then that graph is called as a connected graph. Non-connected graph means if you have two graphs, there is no connection between those two graphs, is called as a non-connected graph. Thank you.